The most recent milestone in ship design provides a solution to the problems encountered with the supertankers. The Sea Snake concept is a novel marine transportation system that is designed to lower the costs of delivering oil from production sites to refineries or storage facilities, while greatly expanding its accessibility to draft-restricted harbors. It is particularly well suited to provide storage at the foot of platforms and can deliver the oil from offshore drilling sites to shore. The essence of the system is a flexible modular ship consisting of a traction unit pulling a train of specifically designed detachable barges, closely coupled to each other by a mechanism equivalent to a ball and socket that, when assembled, behaves as a single hydrodynamic unit. The mothership, or train, remains at a suitable anchorage outside or inside the harbor, while the last unit of the train, which is a modified powered barge, is used as a tug for delivering one or more barges into the harbor and returning any empty ones to the train. The advantages of the Sea Snake concept for moving bulk cargo are analogous to the advantages of the railroads without the disadvantages of being restricted to established railroad tracks. In another sense, the Sea Snake also has some of the advantages found in the container ship concept. The ship does not have to wait while the containers are being filled or emptied. It merely delivers the full containers and picks up the empty ones. Both the cost of construction and the operating costs of the Sea Snake will be considerably less than that of a conventional tanker. This ship can occupy practically all the niches in the oil transport business. It can function as a supertanker when configured as a long train with a 45-foot draft. Or it can function as a small coastal tanker when configured to its smallest dimension, that consists of a traction unit joined to a caboose. It is this versatility, plus its low draft, that makes it attractive to ship operators.
The Sea Snake concept is a unique system of transportation at sea. The system is comprised of a traction unit at the head of a train of barges. The traction unit is coupled to the barges, and the barges are coupled to each other through a system of ball and socket joints.
The advantage of the system is its flexibility. The ability to leave a barge at a location while it's being loaded or unloaded, or to serve multiple locations while keeping the rest of the system going. That to me is the real advantage of the system.
I've worked with Sea Snake in the past in developing concepts for new markets and markets that the Sea Snake could operate in, as well as providing some engineering support in terms of bringing this visionary idea to something that's practical and workable in terms of building an operation. It's similar to a railroad train in the sense that there's a tractor or a tug that pulls a series of smaller barges behind it, and they're very closely coupled together, so they can so they're very efficient in terms of structure and operation. At the same time, like a train, the smaller barges can be left for extended periods while the main unit is doing other work elsewhere.
The Sea Snake is a flexible ship. This greatly reduces the bending and torsional stresses in the hull produced by the waves, which allows a substantial saving in the amount of steel per ton of displacement.
The Sea Snake concept requires less steel and permits a system to be put into service that has less draft than a traditional tanker of comparable capacity. This is of very great importance along the East Coast and the Gulf Coast of the United States, as well as in many overseas ports, where the ports are shallower. Therefore, a Sea Snake system can operate in and out of these shallower ports and in estuaries and river systems where traditional tankers would not be able to operate. This is also an advantage in transiting certain canals where the lock systems are of limited draft and where the lock lengths would not permit a traditional tanker, which would be longer than the individual units, to operate. These are two very important aspects that give the Sea Snake system access to many ports where traditional ships, not only tankers but bulk carriers, aren't able to operate.
The closely assembled barges and the overall elongated shape of the vessel produces a low residual resistance, which translates to a saving in fuel per ton of transported oil. The barges can be individually unhooked from the mothership at sea and delivered into most any harbor. It has been the tendency to build bigger and bigger tankers, known as supertankers. The reason being that as the tanker gets larger, the steel-to-displacement ratio diminishes, and hence its cost. A 50,000-ton tanker has a steel-to-displacement ratio of 14.5%, while in a 300,000-ton tanker, this ratio drops to about 12%. In the case of the Sea Snake SS-45, the steel-to-displacement ratio is constant for any number of barges and is about 11%. Similarly, as the tanker gets larger, the required power-to-displacement ratio drops. In a 50,000-ton tanker, this ratio is 18%, while in a 140,000-ton tanker, this ratio is 12%. In the case of the Sea Snake, the power-to-displacement ratio also drops with size, being about 15% for a Sea Snake of 50,000 tons and 11% for a Sea Snake of 140,000 tons. The cost of the ship is estimated to be about 20% lower than a conventional tanker. The reason being that the ship is flexible and, consequently, is subject to lesser wave-bending moments in the individual hulls, therefore requiring less steel for hull girder strength. The building of the barges and the traction units does not require huge, specialized shipyards. A 260-foot length is workable for any shipyard. The operational cost of the Sea Snake is competitive, as is fuel consumption. The cost of operating the ship is about 25% lower in crew than in a tanker.
The Seatrain power module comprises of our patented tubular linear generator technology developed over the past 10 years by a rigorous R&D and validation program. This was carried out with leading academics at University of Cambridge, Edinburgh and Warwick in the United Kingdom. These generators produce power using the linear motion derived from wave energy, wave to wire. The excess generated power will be stored in a patented state-of-the-art modern liquid flow battery to ensure a constant power output on demand. The linear generators will also act as dampers on the Seatrain modules instead of the original design of pneumatic dampers. The linear generators, while providing full damping to the barge modules, they also produce power, thus ensuring energy capture from the motions of the barge modules in the waterways. The linear generator power pods are simple and reliable. Each module capable of generating 360 kilowatts of electrical energy. A complete system capable of generating in excess of 6.0 megawatts of electrical energy. They are also efficient, proven to 90% conversion efficiency. Cost-effective large-scale machines make use of low-cost ferrite magnets. Modular and scalable multiple generators combined to increase power output. Highly controllable. Full 4-quadrant real-time control. Control system accounts for manufacturing variations and any stray magnetic forces and is a wave-to-wire power converter producing a constant DC voltage for export or local use.